Okay, in this video I'm just going to go over some questions from chapter 4.4. So just looking at question 8 from 4.4, it says sketch the graph of y equals minus x cubed plus 3x squared plus 10x take 30. It asks us to sketch that without attempting to obtain any turning points that do not lie on the coordinate axes. Okay, so to start off, it's not so easy at this stage to sketch this without doing some work first. So what we need to do is find a factor first and put it into intercept form is probably our easiest step. So just looking at 10x take 30. To find a factor, we need to kind of look ahead a little bit. So just from this, my first point is going to look at, okay, if I have x as 3, we're going to have 3 times 10 take 30 is going to be 0. So hopefully that works out here as well, and I think we'll find that it should. So using our remainder theorem, p of, now we'll use positive 3, because positive 3 times 10 take 30 is 0. So p of 3 will have minus 3 cubed plus 3 times 3 squared plus 10 times positive 3 take 30. Now 3 cubed is 27 and we've got a minus there, so minus 27. 3 squared is 9 times 3 gives us a positive 27, so already we can see it's going to work. So 30 take 30, okay, equals 0. So therefore we can say x, now it's going to be take 3 is a factor. Okay. So starting with our original equation y, and now we'll say x take 3 is a factor. And what are we going to be left with? Well, we start with a cubic, we're taking a linear factor out, so we're going to go down a degree. So we're going to have a quadratic. So ax squared plus bx plus c. Okay, our a term is going to be what's in front of the x cubed term from our original equation. Because when we multiply it by x, that'll give us the x cubed. So in this case, a has to be minus 1. So we can say minus x squared. Now c is going to be, what do we need to multiply minus 3 by to get minus 30? Well, it's going to be positive 10 here. So filling in the blanks, we've got x plus 3 and just need to find the bx term now. Next step, can't do much else to find b unless we expand it, so let's do that. X times minus x squared is minus x cubed, okay, plus bx squared plus 10x. And then do the minus 3, so we'll have a positive x squared this time. Take a 3, ooh, that should be 3x squared. Minus 3 times bx and should get minus 30 there. Just tidying up a little bit, so we have minus x cubed, that's the only term there. We'll take x squared as a factor. What are we left with? Well, in this case it's b, and over here we'll have positive 3. Take x as a factor. Our x term, that should be an x there, should be 10 and minus 3bx, and then take 30 at the end. So now we can equate coefficients. So our x squared term, we can say the coefficients are going to be the same. So b plus 3 has to be equal to positive 3. So also our x term should get the same answer. So 10 take 3b, just 3b, has to be equal to the coefficient in front of the x term. which is 10. So now we can say we'll take 3 on both sides, b equals 0 there, and if we take 10 on this side first, we'll get the same answer. Equals 0, divide by 3, we get b equal 0. Okay, that's handy, makes it simple, because we'll have x take 3 from our first factor, our a is minus x squared, b is 0, so we don't have to worry about that, and our c is plus 10 now. Just rearranging this a little bit. Okay, I'm going to swap the x and the 10, so we'll have 10 take x squared. Okay, I'm doing that because I can say now we've got something squared take something squared. A squared minus b squared. So I'll be able to factorise that further as x take 3, now to be a, which is the square root of 10 plus x, the square root of 10 take x as our two terms. Now using the null factor law, solving for our x-intercepts, I can say x take 3 is equal to 0, square root of 10 plus x equals 0, or the square root of 10 take x equals 0. So x equals 3, x equals minus square root of 10, x equals positive square root of 10. Now I can put those into a graph. So positive 3 over here somewhere, square root of 10, that'll be about there, and negative over here somewhere. Okay, connecting the dots. And I've got a negative graph, so it's going to start from the top. And looks something like that. And just last point is our y-intercept at minus 30. Okay, which works. That's what we want. So that's question 8 from chapter 4.4. I hope that helps. It's similar to some of the other questions in there.